Today we are going to start looking at section 3.4 and 3.5. We are not going to do the whole packet today. We're just going to start simple and work our way through. So we're going to be looking at zeros of a polynomial function. We've already looked at zeros a little bit when we were looking at section 3.2 and you were factoring and found your zeros. So now what we're going to do is look at them another way, or how to find them another way to make it easier if you have to find a whole bunch of them. So the first thing we have is what's called the fundamental theorem of algebra. And I talked about this a little bit when we were finding zero. It just tells us that if you have an nth degree polynomial, it has n zeros. So for example, what it's telling us here is your largest exponent is 5. So it would just say that this has 5 zeros. So when you're asked to find the zeros, you will have 5 answers. Whatever your largest exponent is, that's how many answers you're going to have. The rational zeros theorem is one of the theorems we'll use to find possible zeros. Not all of them, but possible zeros. So in this case, our theorem says that we're going to have P over Q. P is going to be the factor of the constant. So P is the factor of our constant out here. And Q is the factor of our leading coefficient. So you have to be able to determine what our factor is and what our leading coefficient is. And then what you're going to do is you're just going to make a bunch of fractions out of those numbers, and those are possible zeros that we could have for our problem. So we're going to use the rational zeros test. You must first list all the factors of the constant and all the factors of the leading coefficient. So remember, factors is a number that goes into that number. So if we look at a couple examples, we want to list, notice it just says list all the possible ones. We know there's 3, but there's a lot of possible ones, so we're going to list them all. So to list them all, we have to know what our P is, and we have to know what our Q is, because remember it's P over Q. So P is factors of 9. So this is what we're going to use with our P. So what are factors of 9? Numbers that go into 9. Well, 1 goes into 9, 3 goes into 9, and 9 goes into 9. That's it. Factors of Q are factors of this number 3 right here. Well, what goes into 3? Just 1 and 3. So now we have to make our possible. So what we're going to do is make fractions out of these numbers. So when we list them, you're going to take, all of our numbers are going to be P over Q. So take your P, let's let P equal 1 and Q equal 1. So I would have 1 over 1, and then I would have 1 over 3. So I've used the 1. Now 3, so I would have 3 over 1 and 3 over 3. And then the 9, I would have 9 over 1 and 9 over 3. When we list them, they can be positive or negative, and we need to simplify them. So now I'm doing a lot of work to get our answer. You'll be able to hopefully simplify this. So 1 divided by 1 right here is 1, and you have to put plus or minus in front of it. 1/3 I can't do anything with, 1/3. 3 divided by 1 is just 3, so plus or minus 3. 3 divided by 3 is 1. Well, I already wrote 1, so I'm not going to write it again. 9 divided by 1 plus or minus 9. 9 divided by 3, I already wrote it, so I'm not going to write it again. So here are my possible zeros. When you put these in WebAssign, you'll have to list them out. You'll have to do 1, -1, 1/3, -1/3, 3, -3, 9, and -9. So in WebAssign on the computer, you have to list them out separate. If you're writing them on paper, you can just write them with a plus or minus in front of them. Okay, let's look at another one. Let me go through all of this. Okay, so again, we need factors of our constant, so these would be our P values. Our constant is 25, so what goes into 25? 1 times 25, 5 times 5, so 1, 5, and 25. Factors of our leading coefficient is 2, so that would just be 1 and 2. So now you have to make your fractions. So start with the 1 right here. So I would have 1 over 1 and 1 over 2. So I've used that one. 5, 5 over 1, 5 over 2. Use the 5. 25 over 1, 25 over 2. I've used the 25, so we're done. Then remember, you can put plus or minus or write them out. I'll write them out separate since it's what you have to do in your homework. 1 divided by 1, so that would be 1 and -1. 1/2 I can't do anything with, so 1/2 and -1/2. Again, 5 and -5. 5/2 I can't simplify, and -5/2. 25 would just be 25 and negative 25. And then we'd have 25 over 2 and negative 25 over 2. Okay, so those are factors that you will be doing, that you will have to find today, your P over Q's. Okay, so that's good. Here's our answer. All right, so next, let's get through all of my answers right here. So that tells us what our possible ones are. So we know that in this case, I want to find all. Before it just said list possible. Now I want to find all. I know I have 3. So from what we did in number 1, we found all these possible zeros. So we need to figure out which 3 of those are our answers. So to find out if any of them are really zeros, start by just graphing your function. So in your calculator, do y equals and graph this. Okay, might need to pause for a minute. Graph, you should get a graph that looks like this. So remember, zeros are where it crosses the x-axis. So I can tell right away it crosses right here at 3. So I know it crosses at 3 because it touches it. It has even multiplicity, which means it occurs twice. I need 3 zeros. I just found 2. And then it touches or right here, but we're not sure what that value is. We need to figure it out. So you have to show work. So you're going to have to show work. So we know we have 3 is even multiplicity. So what we're going to do is use synthetic division that we learned last time to figure out what our last zero would be. So what we would do is on our, for our synthetic division, make our synthetic division. So we're going to put our 3, negative 19, 33, and negative 9. Whatever you got from your graph goes out here. So 3, I got 3 from my graph. So now what I'm going to do is bring down my 3, and we're going to work through just like we had before. 3 times 3 is 9. Add, multiply, and add. When you do this and you get a number from your graph, this should always be 0. Your remainder should always be 0. If not, you've looked at the graph wrong or you've done some math wrong in here. Because 0 occurred twice, I'm going to do this continue synthetic division one more time. Okay. Bring down my 3 again because my 3 happened twice. We're going to do it twice. I have 9, negative 1, negative 3, and 0. Okay, you can ignore this last 0 when we do it again. So then we can figure out, okay, well, I need to put x's in. So my highest x here was x cubed. So when I did synthetic division this first time, if I would have put x's in here, it would have been x squared and x. So now go down one more than that. So this is just going to be 3x minus 1. We'll set it equal to 0 and solve for x, and I get x equals 1/3. So my zeros are x equals 1/3 and x equals 3 with multiplicity of 2. Okay, so all it was asking us to do was find our zeros. Okay, so that is what our whole assignment is going to be about. Ignore all my stuff over here. So we could also write them as linear factors. Once you find your zeros, we know how to write them as linear factors. We've already learned this. The complete factorization theorem just says that you write them as linear factors instead of just listing them. We can write our polynomial. So if we know what our linear factors are, we're just going to write them in here. Okay, it tells us that the nth degree polynomial is factored into n factors. So if I found 3 zeros, I'll have 3 factors. If I found 5 zeros, I'd have 5 factors. It just depends on what's going on. So we're going to find our zeros, and we're going to write it in factored form. So we're going to do 2 things. So we could go through and we could find all of our p's over q's, right? We could list out all of our possible answers right here. So our p values in this case would go with 15. So this would be 1, 3, 5, and 15, and our q's would be 1, 2, and 4. And we could list out a bunch of possible things, but the easiest way to start is always to graph it. So plug this into your calculator and graph it, and you're going to get a graph that looks like this, or should be similar. Your window might not be set exactly the same. The important point, I know I need 3 zeros because of this 3 right here. We want to find the one that is exactly on a number. So right here you can see that this crosses at -1. So you're going to take the one number. These other 2 are in between numbers, so we're not exactly sure what they are. We have to figure it out. So we're going to take where we got it from our 0 right here. We're going to take -1 with our synthetic division, bring our numbers down here. So I'm going to have 4, negative 12, negative 1, and 15. And then we're going to work through this. So if I bring down my 4, remember we multiply negative 4, negative 16, multiply, add, multiply, and add. Remember, this should always be 0 if I get it from my graph right here. Okay, when you do this on your assignments, when we get to things, you have to be able to graph your function. You'll have to sketch a quick graph to show me where you got this negative 1. Okay, now that I have that negative 1, I only got 1 from my graphs. I'm only doing synthetic division once. What we're going to do here is you're going to have 4, put in our x's. Since I started x cubed, it's going to be 4x squared minus 16x plus 15 equals 0. To find our other 2, I need to factor this. So you're going to have to remember your factoring. So go back, remember when we factor, we multiply our AC method 4 times our 15, and we redo this. So when we multiply 4 times 15, we get 60. So as a quick reminder, we need to multiply to get 60 and add to get our middle number of negative 16. So in this case, what multiplies to give me a positive 60 and adds to give me 16. So remember, if you need to, think about it. What multiplies to give us 60? You can do your y equals in your calculator. You can do 60 divided by x. And then if you hit your table, it will show you all the different numbers. So I need to multiply. This would be negative 6 and negative 10. They add to negative 16, multiply to 60. So I'm just reminding you how to factor right here. So then when we do that, it's 4x squared minus 6x minus 10x plus 15. Then when we factor, we group our first 2 together and our last 2. So my first 2, they have a 2, take out our greatest common factor, a 2 and an x, left with x minus 3. Oops, did not mean to do that. In my second one, I'm going to take out a 5 they have in common, but it's negative. So I'm going to take out a negative 5. Then I'm left with 2x minus 3. This should have been a 2x minus 3 over here. Messed that up. Remember, when we're factoring, what's in parentheses should be the same. So now if I take out a 2x minus 3, I'm left with 2x minus 5. We still have that equal to 0 from up here. Set each factor equal to 0. So if I set 2x minus 3 equal to 0 and 2x minus 5 equal to 0, this would give me x equals 3/2. This would give me x equals 5/2. Okay, so there's my other 2 zeros. So my zeros, if we list them, we had 3. I have negative 1 from my graph. I just found 3/2, and I just found 5/2, which makes sense where there are. So here's my zeros. That was finding them. Writing it in factored form simply means you're going to have f of x equals, and we've factored this down, so it's just going to be x plus 1. Okay, you can't put fractions in your factors. Normally what you'd think about is you'd do x minus 3/2 and x minus 5/2. Well, we can't do the minus 3/2 and minus 5/2. So this is going to be x plus 1. All you're going to do is move that number that's on the bottom of the fraction in front of your x. So this is going to be 2x minus 3 and 2x minus 5. So there's our factored form, and here's our zeros. We're going to do a couple more examples of these before you get going. All right, so here's another one. Find the real zeros and write in factored form. Same thing we were just doing. Again, we could list them all out with our p's over q's, but let's start graph it. So put this in your calculator. You should get a graph that looks like this. Yes, you have to sketch the graph. Keep that in mind. I will count off if you don't sketch the graph on your problems. So you can see right here that negative 1 happens. And it just touches it, which means it has multiplicity of 2. So again, I'm going to do negative 1 with my synthetic division. I'm going to have 3, 4, negative 1, and negative 2. Bring down my 3, multiply, add, multiply, add, multiply, add. I got 0, which I should. Because this is multiplicity of 2, that means, guess what? I'm going to use it one more time. So bring down my 3 again, -3, -2, 2, and 0. We ignore this when we do our synthetic division. Add our x's. So I started with an x cubed. This first one would have been an x squared, so this is just going to be 3x minus 2 equals 0. So x equals 2/3. So my zeros are x equals 2/3 and -1 with multiplicity of 2. Multiplicity. So when I write this out, f of x equals, remember I'm not going to write x minus 2/3, move the 3 over, so 3x minus 2. And then I have x plus 1, and because it has multiplicity of 2, that means I have to have a squared on there. So this would be our answer. 3x minus 1 and x plus 1 squared. Okay. Questions, let me know, ask in class if I'm here. So last example we're doing, number 6. We're doing the exact same thing. Find the zeros in factored form. This time I have an x to the 4th, so I should have 4 zeros. So the first thing you're going to do, graph your function every time. Put this in your calculator, graph it. Yes, again, you need to sketch the graph on your paper. I have to know where you're starting. Where do zeros occur? So I have one right here at -2. Not sure where this one is, or this one in the middle, the 2 in the middle, but then this one right here is at, whoops, that's not -2. Just kidding on here. This is +2. This is -1. So I got 2 zeros. Pick any one of them. It doesn't matter. I'm just going to start with -1 because it's the smallest. Work through synthetic division. So up here I'm going to have my 6, -7, -12, 3, and 2. Bring down my 6, -6, -13, multiply and add. You guys should be pretty good at synthetic division by now. Again, I should get 0. Because I got 2 zeros from my graph, I'm going to do synthetic division twice. So the next one, it doesn't matter which number you use first, use the second one the next time. Bring down my 6, my 12, -1, -2, -1, -2, 0. Remember, we ignore this, and I should get 0, which I did. So now we need to put our x's back in. So think about it. I started with x to the 4th. This would have been x cubed. So this is going to be 6x squared minus x minus 1 equals 0. So again, I need to factor. So factoring, what multiplies, if I multiply right here, gives me -6 and adds to give me -3. Oh, just kidding. I don't know where the -3 came from. Adds to give me -1 in the middle. So this would be -3 and 2. They multiply to -6, add to -1. So I have 6x squared minus 3x plus 2x minus 1 equals 0. Do our factors. The first one I can take out a 3 and an x, left with 2x minus 1. My second set doesn't have anything in common, which means I just bring out a 1, and I have 2x minus 1. So now 2x minus 1 and 3x plus 1. If both those are equal to 0, for my first one right here, I would get x equals 1/2. For my second one, I would get x equals -1/3. Makes sense with what my graph is showing up here, that those are possibilities. So if I list them, I'm going to have -1, -1/3, 1/2, and 2. It doesn't matter what order you list them, just list them. And then I'm going to have, write them in little your factors, f of x equals, so I would have x plus 1. Remember this -1/3? It's these factors that you got right here is what you'll be writing. So that would be 3x plus 1, and then 2x minus 1, and then x minus 2 as your linear factors. So that is what your new lesson is today. Please let me know if you have questions. We will talk more about this next class. You will not have a quiz. I will review it with you, and then we will finish our notes and add to it a little bit.